Hello, everyone. Thanks for joining. I'm going to put us on pause while everyone logs in. Hello. Thanks for coming today. I appreciate you joining our webinar. This is Leah Freeberg from Fluke Reliability. And you probably know Fluke is a test tools provider. You may also know that we produce some of the industry's favorite reliability tools, from infrared cameras to vibration meters. But you may not know that many of the measurements that our tools collect now flow automatically into EAM systems of record. It happens via a framework that we call Fluke Connect. Our goal at Fluke Reliability is to better connect asset management data and teams with asset management systems to drive connected knowledge. But of course, that knowledge depends greatly on best practices in condition-based maintenance. So that's why this series of webinars explores reliability maintenance strategies, and that's why we feature speakers from a variety of expert backgrounds. Before the presentation, we have a few housekeeping items to go over. Today's session is being recorded, so the phone lines will be muted to minimize background noise. We will be answering questions both during the presentation and afterwards during Q&A. So take a minute now to find the questions tool and go to Webinar Dashboard. I can see a few of you in there already. Thank you. Please feel welcome to submit questions as we go. I will share as many of your questions as time allows for with our presenter to answer at the end. If you'd like to receive the slides from today's presentation, please let us know. There will be a survey that appears at the end of the session, so don't hang up until the survey appears and you've answered the questions. We're also happy to send you a certificate of attendance after today's webinar. You'll see a question on the survey about getting a certificate, and if you answer yes, we'll send one to you. A recording of this webinar will be available on excelix.com within a day or two. And that is it for housekeeping. So now on to the main event. Today, we are very pleased to have with us Shon Isenhour of Eruditio. He's a well-known educator in asset management and organizational change leadership. Shon will be presenting on exploring the tree of unreliability and what drives downtime. So as you may well know, Shon is a founding partner of Eruditio, a reliability education consulting firm. He specializes in adult learning, leadership, asset management, and reliability engineering. Shon is an expert at implementing holistic reliability solutions using tools such as total productive maintenance, reliability-centered maintenance, and root cause analysis, as well as Six Sigma and Lean to drive bottom line results. He's a certified maintenance reliability professional and a certified asset management assessor, and has been accredited by Prosci and Colorado State University as a change management professional. Welcome, Shon, and thanks for being with us today.
Thank you, Leah. It's great to be here and looking forward to spending the next hour with you guys.
Excellent. So from what I can see of the audience so far, you've got some fans listening in. So I want to encourage everyone again, ask questions as we go, and we'll try to insert them in the flow. If not, we'll get to them at the end. Shon, I have one question before we start. I've not heard of the tree of unreliability before. Is this a new concept?
It really is. It's just something I've been kind of playing around with, and it's really, and I think you guys will see this as I go through today, it's really an explanation of why I so often talk about some of the topics that I talk about. So for those of you that have seen me do the Fluke Reliability sessions in the past, you're going to see some of those topics very briefly at the end, but today is really about using that tree to explain why those things are so vital to the success of most organizations.
Excellent. Thank you. All right, well, why don't you kick it off?
Very good. Well, thank you. Well, we'll go ahead and get started. A little bit about me outside of work. Again, my name is Shon Isenhour. I live here in Charleston, South Carolina. In fact, I'm coming to you today from one level down on the flight deck, or one level down from the flight deck on the USS Yorktown, which you can see up in the upper right-hand corner there. This is our office and headquarters, and so I'm happy to be back here on the ship this week. We've been doing a lot of the work from home thing, like many of you probably have as well. But today I am definitely enjoying being back here on the ship. We've got a training class going on the other side over here, and we've got some online training classes going as well this week. So it's been a pretty fun and exciting week from that perspective, kind of getting back into the groove of the way things have been in the past. A little bit about me, though, outside of work. That's my daughter up in the corner there. She's a little mini me, and a big part of the things that I've been doing over the last 5 months. Probably a lot like you guys. Schools have been canceled. Schools have been online. So I've become a teacher for young folks as well as the adults, and maybe I better stick with the adults. But with that said, that's my daughter. I do enjoy a lot of, I would say, kind of exciting activities when I can fly airplanes and race cars and that sort of thing. And reliability comes a very big part of that. Because as you think about getting into that helicopter or you think about getting into that race car, you've got to be able to go reliably from point A to point B. It is really hard to pull a helicopter over at 3,000 feet. So reliability is a really important part of my life in general, and the activities that I like to do. So I do have a blog page where I share some of those stories. It's called reliabilitynow.com, and you can see that down in the corner. So that's a little bit about me, but let's go ahead and get started into the content. With that said, Eruditio is located here in Charleston, as I said, and if you want to see more about what Eruditio does, you can check us out at eruditio.com. So today we're going to be talking about unreliability in this tree. And really and truly what we're talking about are the roots of the tree, but they don't make very good pictures. So I've put a nice big tree up here, but we're going to look at the roots of unreliability. What is causing your organization to struggle to get to where you want to be from an output standpoint or a cost standpoint or a safety standpoint? And I'm going to show you some examples. I'm going to bring some real examples to the video screen as well as to the slides. So if you are in a situation where you can see both of those, I will share a few things from a video standpoint as well. But before we get started, because we're getting into those roots, we're going to be digging down into root causes, and I'm going to talk a lot about root cause here this morning. One of the things I'd like to know from you guys are you using trees? Are you using fault trees and logic trees today to help with your RCA efforts? So if we can go ahead and launch that poll, you'll see that there are 3 answers. The first answer is yes, we use them regularly. The second is, yeah, we know what they are, and we've probably had some training on it, but we're not using them really. And then third is like, what in the world's a fault tree? All right, so there's your options there. Go ahead and respond to the poll if you don't mind. Just give me kind of an idea of what the audience looks like from an experience standpoint, and that'll help me kind of tailor the content you're going to see over the next few minutes.
Looks like we already have about 60% of the audience chiming in. We'd love to get 3/4 of the group so that we really have a good feel for everyone's familiarity with the topic and level of usage. So we're really close right now. And again, do your best to select the answer that makes the most sense for where you're at. You use fault trees or logic trees regularly. You know what they are, but you don't use them. Or what is a fault tree? And I'm going to go ahead, give it 10 more seconds, and I'm going to close it out. Looks like we've got most of the answers, and I'm going to share the results now. Shon, it looks like you've got 22% of folks using it regularly, 47% know what they are but don't use them, and 31% are curious about what a fault tree is.
All right, well, very good. Well, I will take that and kind of build off of that as we go forward. So thank you so much, Leah.
It's great feedback.
So today this is our outline, if you will. As you look here, we're gonna talk about these tree tools, these fault trees and these logic trees here for a few minutes. We're gonna talk about the fact that there are 5 levels to these fault trees, and this is one of the very common problems I see with a lot of people that are doing root cause analysis is that they don't necessarily dig down into these 5 levels. So I'll talk about why they're important, but I'll also take you through what they look like and how you might use them. The next thing I'm going to talk about is a concept that I haven't really seen a lot of others really reference, but it's this idea that when you really dig into a fault tree or a logic tree, it actually begins to take on the shape of a diamond. So we'll spend some time talking about that. And then the last thing that I'm going to kind of close the day with is a look at two of the levels. And those two levels are the systemic and latent level. So we'll dive into those and I'll show you a little bit of content to kind of give you a point for what I mean when we talk about systemic and latent. But here's where we're going to start our day. And this is an example of the tree. This is the roots. If that failure box up there is the trunk of the tree growing up from there, then what you're looking at here is an example of all of the roots that are going down into the problem. Now you'll notice I'm using very importantly, I want it to be very obvious, I am using an S on roots. One of my struggles is sometimes I feel like we rely too heavily on things like 5 whys, where we really don't focus on both the actions and conditions that are occurring. So when I say roots, I'm thinking that there is not one cause to a certain issue. There are causes that came together that allow that to happen. And in our root cause training, we'll talk a lot about those instantaneous actions and those long-term conditions that exist. And they all exist at each level. So that's why we say there are roots and not just a root cause. Now, as you look at this, it's a simple example. The boxes, some of them you can see have X's in them. The X means that we've gone out onto the shop floor, or we've gone out to the failure, or we pulled up the data related to the failure, and we've proven that that box didn't happen. So it has been X'd off, and we've put down there on the bottom of it exactly why we X'd it off. So where you see those terminating X's there, that is why they stop up in the physical root. Now, you also see my levels that I talked about a few minutes ago. There is that physical root, that human root, that systemic root, and that latent root. The first of the 5 is that failure up there at the top. So that's how we get our 5 levels. And if you think about the physicals, you think about things that you can see, things that you can touch, conditions that exist. Those are typically physical roots. When you think about the human level that you see here, now we're talking about someone did something. Billy over-tightened the bolt. Tom didn't use Loctite. Whatever the case may be, those are very much human examples. The operator didn't open the valve in time. So those are going to be that human level. Now, I'm going to stop there, and I'm not going to quite talk about the other 2 yet, because my guess is many of you also stop there. You don't necessarily drill down to that lower level that we're going to talk about here in just a second. As I go in and look at a lot of root cause investigations, I will typically see this kind of a response. I walk in, they were down for 8 hours yesterday. I look at them and say, hey, you know, what was the root causes for you guys being down for 8 hours yesterday? And they look at me and say, well, we did a root cause investigation and the gearbox locked up. Well, the gearbox locked up is very much a physical cause. In fact, even the bearing locking up inside of that gearbox that allowed the gearbox to lock up is a physical cause. And a lot of folks want to stop there. They don't want to dig down into the lower level. But if I replace that bearing in that gearbox without understanding why the bearing failed, then what I may see long term is that that bearing fails again. It may fail very quickly, depending on what the real causes were for that issue. Now, there are other organizations that I've worked in over the years where they just really wanted to drill down to the human level. In fact, all they really wanted to do was blame somebody. So we're going to talk about that a little bit and what that drives from a cultural standpoint. But if you are in one of those organizations where traditionally you have gone in and just, you know, looked for who did something wrong, then you are probably stopping at the human level. And I'll tell you, years ago when I first started doing RCAs, I am guilty as charged. I would very much start diving into the problem, and I would stop once I knew that it was an individual or a person that I could kind of pin the root causes on. So I would challenge you that you want to get past that. because even if you kick that person out of the organization, there is probably underlying root causes that will allow that thing to happen again. And that's really how we transition into this next level, what we call the systemic level. And systemic, think about that word system. It's what allowed someone to make a mistake. So if a technician up in the human root has over lubricated a bearing, and now that bearing has heated up and it has failed, causing the gearbox to seize. All right, I've given you some physical causes, I've given you the human causes, but at the end of the day, I haven't told you how it got to that condition. In reality, there's a pretty good chance that no one had given the proper training, as an example, to that technician as to how much lubricant should be put into that bearing. Or maybe they didn't have a standard. So they didn't know how many shots of grease to put in that bearing. So they've gone and just put what they believed was the right thing. Or maybe they hadn't heard of condition-based lubrication, or if they had, they didn't have the ultrasound tools to do that. So there's a lot of things that can come into play at this system level that allowed the human to make a mistake. Now, if we drill a little bit deeper down below the systems into the latent causes, what you're going to see here are the things that allowed the systems to exist. I like to think of them as cultural. For instance, if your organization doesn't believe in precision lubrication, if that's not something you value down at the latent level, then you're probably not going to have good systemic lubrication standards, which means Billy Bob is probably going to put however much grease he wants at the human level, and you're getting bearing failures at the physical level, which is causing you downtime up there at the failure level. So you can kind of start to see how this fits together. Now, what I will tell you, as you start to dig into these, you're not always going to put solutions in at the latent level. In fact, if you look at that curve over on the side, you can kind of see how it slides out. It's telling you that as you dig deeper down into the problem, it can take more effort to be able to do that thing. So if I say to you, which is easier, can I address a physical root and replace a bearing in a gearbox, or can I change the culture's or the organization's attitude toward lubrication practices? You're going to say, I'll change a bearing any day of the week because I can do that in 4 hours. Have you tried to change these meatheads? They're not going to change for years. So it is harder sometimes to address problems at the latent root. But what I'll also share with you is if you address things at that systemic and that latent root, you get more results. You get more change. And the example, again, going back to the lubrication, if I change one bearing, I might get rid of one failure. It may reoccur. If I change the organization's attitude toward precision lubrication, then what I've done at that point is I've actually fixed a whole bunch of problems on everything that's lubricated within the facility. So while it can be harder as you dig down into the latent roots to get it implemented, it also can come with a bigger result factor moving forward. So one of the things that we try to get folks to understand when we talk about root cause is, yes, we do want to drill down to the systemic and latent roots, and then we look with a business case mind for what level we're actually going to address this issue at moving forward. So sometimes that'll be at the human, and I'll go have a discussion with an individual about a problem that we've had, because that's the most economical solution. Sometimes it will be putting a system in place to prevent humans from creating those errors. And sometimes it'll be trying to change the culture of the organization because I need that fixed in order to support the other things. Now, the other thing that I'll tell you about this is if you look at the systemic and latents, it will help you even if you put a solution in play at the human level or the systemic level. And the reason is because now you know why it happened to start with, and you can make your systemic improvement work the best it can for the situation you find yourself in. Now we could spend another 2 hours on this slide, and I don't want to beat it to death, but I wanted to kind of lay this groundwork because this is our tree. These are those roots that if we get these roots addressed, then that tree will be healthy. But if we don't get these roots addressed, this will become our unreliability. Now, I like to show real examples, and so I've got a couple here. You're not going to be able to read the boxes on these slides, and that is absolutely intentional because these are real. These are real examples from real facilities. In fact, what you're seeing here at the top of the screen is an organization that was looking at instability in a certain line within their facility. And while I don't always suggest using a tree for such a big problem, sometimes from a cultural standpoint, I need them to understand all of the factors that are contributing to the issues that they have. Because I think sometimes we have our pet area that we want to focus on. You know, someone says, well, you know, if operations would just run the equipment right, we wouldn't be having this problem. Well, yeah, sure, that may be a piece of it, but just like I said earlier, there's no such thing as root cause, it's root causes. You're gonna have to dig into all the things that are contributing to it. So, you know, occasionally I will choose, even though it gets messy and even though it gets really broad and it's really a little over the top, I will choose to go ahead and use a tree tool to help people understand all of the aspects that are applied to that instability or that unreliability or that high cost. And so you can see this example and you can see how many post-it notes they wrap all the way off of the whiteboard and onto the window. You can see them over on the window behind the gentleman who are talking. We took that and we put it into Excel very quickly down there at the bottom, and that's kind of the first example of that. It's not fully completed. We haven't drilled all the way down into systemic and latent roots, but it is starting to form out, so you can start to see that there are a lot of boxes there. A lot of boxes. So that's one example of exactly what I'm talking about today, and that is, you know, what is causing reliability issues within your organization. And I don't mean the bad bearings and the worn out gearboxes and the belts that need to be replaced. I want to know why those things are happening, and that's where we're headed today with the presentation. So here's another example, and the point I want to make here is a lot of folks think that root cause or 5 whys is 4 or 5 boxes, and you know, you go through and you toss a couple boxes on the screen and you're done. And I've got an example of that I'll show you here. More quality defects. Well, that's coming from the machine condition and it's coming from startups and shutdowns. So here's the problem. Y'all go fix that and we'll all be good. But at the end of the day, this is not enough effort. This is going to lead to reoccurring failures. So if you've struggled in the past with your fault trees, I would say go back and look at them and see if you've got more boxes or if they're really simple. So the example that I showed here, you can see there's about 20 plus boxes going on here. And I would suggest to you, even on very direct problems, there ought to be at least 20 boxes in your analysis. Now, what I would suggest is 20 boxes is really only getting you started, but what I see is so many or so much less than 20 that is at least a good effort. So it's a good way if you're going back and looking at what you've done in the past or looking at what others in your organization have done. It's a good way of kind of gut checking what's going on. I'll give away 2 secrets right quick before we move on. When we do a lot of coaching for our students, and our students submit their fault trees and their logic trees to us, and so we get to see what they're seeing and how they're thinking about it. And the 2 little secrets I'll give you is the 20 boxes. If they don't have at least 20 boxes, I'm pretty sure they're not done. And then the other thing is that as a coach or as someone who's looking at what they're doing, I want to read the tree from the bottom up, not the top down. If I read it from the bottom up and I don't get the thing above it every single time, then I would suggest to that student that they've missed something. They've left out a facet of the problem that they're addressing. So it becomes a great way to kind of check and see, did you get all of the things that were causing the box above it to happen? Now, I'll tell you why that's important, because I bet some of you out there have dealt with what we call the gremlins, right? Those problems that come and go and nobody really knows why they happen, and it seems so random. and it's very hard to understand what's happening. What I have found is if you will read from the bottom up and you will make sure that you get the thing above it every single time, many times you can uncover some of those gremlins. I had one a few years ago where the failure was only occurring on the piece of equipment if you had a certain style of product on that line with a certain package on that product with temperatures above a certain temperature and a certain carrier being used to carry that product. So you start seeing when you go through that investigation that you don't have everything to get the thing above it every time. And you dig a little deeper, and voila, you discover that it takes these 3, 4, 5, 6 things coming together to give you the step above. And that's my way of eliminating gremlins within an organization, and that can save a lot of money.
Shon, I have a couple questions from the audience for you.
Yes.
I think you've just said that 20 boxes is the minimum for your tree analysis, right?
Right.
Okay. Do you use FMEA in your RCA?
Oh, that's a great question. Thank you. Yes. So when we teach RCA here at Eruditio, we teach 10 tools. And we believe that you really need 10 tools in your toolbox. A lot of people think you can do RCA with just a fall tree or just a 5Y or just a fishbone. I would suggest to you that equates to you picking up one screwdriver and going out to fix your car.
Right.
At the end of the day, you've got to have a set of tools to be successful at root cause. So absolutely, an FMEA is what I would use in many cases as a tool for investigating these big organizational problems like we're talking about today. In fact, if you go back to the real life picture that I showed earlier, if I was trying to be efficient there, I would have used an FMEA. But I wanted to be effective in convincing them that there were more than one thing coming together to give them the problem. So that's the reason I chose the tree.
Okay.
So I could have been more effective with the FMEA, or sorry, I could have been more efficient with the FMEA, but I chose to be more effective and less efficient in using that big tree. So absolutely.
Somebody else wants to know about that scenario you showed us. Who should be on the team?
Oh, wonderful question. So who should be on the team? Um, so I like to use triggers, and I don't have enough time to get into all the process side of reliability today, but I love to talk about it. So if you want to reach out to me
Good.
afterwards, I'll get into more detail. But let me address that question. I like cross-functional groups. If the problem is big enough to warrant an investigation, right? If it meets your triggers to give a real root cause investigation, then I want an operator involved. I want an electrician. I want a mechanic. I want a reliability engineer or a maintenance engineer. I want a supervisor. I want operations involved, whether that be operations supervision or whether that be operators directly. You know, I want a mixed team of folks involved. And that's for two reasons. One, because they bring a lot of great information to the table. But the other, and maybe the less obvious one, is that they will ask what I call the dumb questions. They'll ask things that no one else will ask because they're not as close to the problem. And if you're not comfortable asking dumb questions as a facilitator of root cause analysis, you will not be successful long term.
That's an
Because
awesome one.
many times the real cause is buried in an area you're not used to addressing.
Last question. How do you, and this is
Yes.
an interesting one, how do you prove the failure mode in RCA analysis? And I almost want to say, do you need to? But how do you is the question.
You do need to. You need evidence in order to put a strategy to go after that and eliminate it. Now, what I say, I don't always say eliminate. I say that you are going to find the solution that reduces the risk to an acceptable level for the amount of money you're willing to pay. And I know
Right.
that's a mouthful, but for me, that's absolutely critical. That's first. And then the second answer to your question is I do want to try to prove it. So I'm not going to put a solution, I'm not going to spend a lot of money to put a solution in play for a causal event or a causal chain that I don't have some data or something to back up. So yeah, a lot of times I will use predictive tools to try to verify if something happened. I will use forensic data from the failed components to try to verify what happened. I might use DCS or PLC data, video. I had one time where a security video was what we needed in order to have the data to know that that thing happened. But you really do, even though you sometimes put assumptions down in the tree, you really do need to verify those assumptions before you start making decisions and implementation based on it.
Excellent. Back to you.
Awesome. Thank you, Leah. So real quick, I'm going to talk about this one, and this is for those of you that are stuck in that culture where sometimes you dive into your problems, but unfortunately you get into a situation where it's just about finding someone to blame. And in that situation, I see it pretty regular. And so jokingly, a few years ago, I put together this somebody's fault tree, and I said, you know, hey, if you're living in an organization where somebody always wants to blame somebody else, then I ought to give you the best tool I can to get you out of trouble. So I built this somebody's fault tree. You can find it on my blog as well, the Reliability Now blog, but I divided it into 3 categories. So your fault, not my fault, and their fault. And underneath that, I've put some quotes, and I'm going to read some of these off to you. And I want you to think about when you were doing an investigation recently, or when you were brainstorming the problem out on the floor, did you hear these words? Because if you heard these words, it's not a good thing. I'm poking fun at having a good time with it. But at the end of the day, it tells me that the organization is trying to stop at the human roots. So you did it, and I can prove it. You didn't follow the procedure. You didn't watch what you were doing. You didn't know, you didn't do what you said. You didn't think before you acted. You were asleep at the wheel. If you just listened to me, this would never have happened. You didn't update the procedure. You didn't provide me the information I needed to make a good decision. All right. So here I'm deflecting everything to you. It's your fault. Now that's dangerous, because if you're really quick on your feet, you might be able to turn that around and get it back into my court. And I feel like sometimes the morning meeting is really not about getting to the root causes. The morning meeting is more about making sure it doesn't fall in your department's list of things to do. So maybe I won't go with the red one. Let's go with something a little safer. What if I could just say it's not my fault? I'm not going to say it's your fault. I'm not going to say it's their fault. I'm just going to say, hey, I didn't do it. It's not my fault. All right. So some of the things you might hear there, there's some way it's their fault. It might even be your fault, but it's not my fault. It's my parents' fault. It was an act of God. Blame it on the dogs, the kids, the neighbors. The data was wrong. Obviously, stuff just happens. And my personal favorite, my boss told me to. I was just doing what my boss said. So it's obviously not my fault. So again, you know, if you're hearing those kinds of things, I would suggest to you that you are in that people level. You have not drilled through that yet. Now, the next thing that you see, and this is the safest of all boxes, it's the one you go to when you really want to stay out of trouble, and that's the their fault category. In other words, it's somebody else's fault. They're not in the room, so let's blame them. So let's look at some of these. They're not here, so it's definitely their fault. They said they would do it. I heard they did it too. If they had done it, they would be here. They didn't guard it from happening. They didn't give me the money to do it right the first time. They never give me enough time. They're just plain lazy. They never pay attention. Heck, we tried to tell them. All right, so again, I use this somebody's fault tree, you know, as a tool to defend yourself in that morning meeting, but really in jest. And what I want you to think about as you think about this slide is, how many times have you heard phrases similar to these uttered in your meetings, in your problem-solving sessions? And if you have, you really need to get past that people side and get down into those systemic and latent roots we talked about earlier. So with that said, let's launch another poll. I'd like to know how many of you, for those of you that are using fault trees on a regular basis, and I know this may be a smaller group, how many of you are doing 20 plus boxes that have both actions and conditions at each level? You know, how many of you are in that category? The second one is, well, you know, how many of you are using 5 whys or simple fault trees? And then the third is going to be our group of folks who just aren't using fault trees at all right now. So we'll give you just a minute to take a look at that.
As with last time, we'd love to get close to 3/4 of the audience, so take a minute and vote. And yes, you do get to select only one, sorry about that, but select the one that is the closest to your situation right now. And we've got about 62% of the audience in. I'm going to give it another 5 seconds and close it out. And by the way, Shon, people really liked the blame slide. They're getting a lot of positivity about that. All right, I'm
Yeah,
going
it's
to
a
close
funny.
this.
All
Yeah.
right, good.
So 11% say yes, we have 20 or more boxes with actions and conditions. 45% say no, we're sticking to the 5 whys or simple trees of 10 boxes, and 44% are not using fault trees.
All right. So it looks like we've got some area for improvement here as we go forward. Things that we can do. So if you want to talk more about it, reach out to me. I'll explain more, how to get there, how to get away from those 5 or 10 boxes. I'm not saying that 5 or 10 boxes aren't something that I use. It's just not something that I use every time. If I'm out on the shop
Right.
floor dealing with a breakdown, I may choose to use it just to get my thoughts. But if it's meeting your triggers in your process and you're actually doing an RCA, we really need to expand out a little more. So let's take a look at what that looks like. And I did this specifically for this webinar. So this is a fault tree that I sat here and just kind of worked through. And what I said was, up there at the failure level, I said the plant output is falling. We are not getting the throughput that we need. And I started to look at that and I said, okay, what are the 3 reasons or 4 or 5 that we might be seeing plant output falling? And one would be, of course, more downtime. If I have more downtime, I'm going to get less product out the door. If I have more quality defects, I'm going to get less product out the door. And if I have lower production speeds, I'm going to get less product out the door. So you'll also, for those of you that are OEE or overall equipment effectiveness users, you'll recognize that as well. It's one of those things that really makes up the equation for OEE. But then I started digging a little deeper down into those, and I'll show you some of these here in just a second as I break them down. But I started looking at, okay, let's get past the failure and let's get down into those physicals and then into those humans. And I'll show you an example here next. So all I've done is drill down into one of the branches so that you guys can see it a little bigger on your screen. And one of the things that I saw was that my PM requirements are expanding. Our PMs are getting bigger. I call them pregnant PMs. They started out taking 2 hours, but then we had a couple failures in the middle of the night, and so we added a few more steps to it. And we had a belt break the other day, so now we're going to replace the belts every 6 weeks. We're not going to have that happen again. So those PMs continue to get bigger and bigger and bigger over time. So how does that happen? Well, let's look at some of the causes. So the team is adding PM tasks. That's one reason the PM requirements or the time needed to do PMs could be getting bigger. The team has not optimized the preventive maintenance strategy and based it on failure modes and look to make sure that it's repeatable. All right, and then the last one is the team is not utilizing condition-based maintenance, because CBM, condition-based maintenance, or predictive maintenance as some people refer to it, those tools can allow us to do more inspections in less time. And they can also, in many cases, even be done while the line is running. So there's a lot of value over there. So again, we drill deeper down into each of these, and you can see that I'm not going to read the whole thing to you, but you can see I'm drilling down. But my point here is I have still only taken us to the human level with most of these causes. All right, the first systemic box on this chart is the one that says evaluation criteria do not exist. So even now, I haven't gotten down into the deeper underlying causes. If you're using, if you're not, as I said, digging deeper down into these, and I just blew it up again so you could see another element or another area, but if you're not digging down further into these, then I would suggest that you will probably see those reoccurring failures coming back again. Now, I've expanded even further on that. What I did is I took the one you saw previously and I continued to build deeper down into the systemic and latent roots. Now, because I chose plant output, that is a really big problem, which means, in essence, if I really did a good job, this thing would cover 5 or 6 screens. It would be a nightmare. It would have boxes everywhere. So this is one of the negative drawbacks, as I referred to earlier. This is one of the negative drawbacks of using a fault tree on these really complex problems or these organizational issues, is that you're going to end up with a lot of post-it notes or a lot of boxes as you create and investigate the problem. Now, if you just have a gearbox that failed, the fault tree is actually really good because you will start expanding out. And I've got an example of that I'll show you here. You'll start expanding out and you can kind of get your problem addressed pretty well in that 15, 20, 30, 40 boxes range. But for these bigger systemic organizational issues, you're going to see a lot of boxes as you get down and try to understand it. But one of the things I mentioned I wanted to talk about today is the fact that there is a diamond. And this diamond is something that I've kind of discovered as a way of knowing if we've really exhaustively looked at the problem. So if it's eating your lunch, if it's causing a lot of downtime, if it's a safety issue, if it's really driving poor performance in the organization, and you've done a really good investigation from a fault tree, then it should broaden out and then come back into a diamond. And I'll show you what I mean by that. And that is the gist of today's presentation. And I want you to remember that it comes back to a point if you dig deep enough. In fact, if you think about a tree, if we were to go out in your front yard, find that new tree that you just planted, because everybody's doing yard work during the COVID crisis. So you find that new tree out in your front yard, you jerk it up out of the ground and you give it a little shake till all the dirt falls off. What you'll see is those roots get real broad just under the surface of the ground, and then they start to narrow down to one singular root that digs deeper and deeper, hopefully digging down for water to make that tree grow well. And what we see is the same thing happens with our root cause investigations. If we really dig down into systemic and latent roots, they come back together and they rejoin into a solution. So my question to you is, when you're looking at your root cause investigations, are you looking at the systemic and latent roots? Are you digging down into the systems that allowed somebody to make a mistake, or the culture that allowed no systems to exist, which allowed someone to make a mistake? So take just a second and give us a little feedback here. Yes, we do dig down into systemic and latent roots, and we use business case thinking to decide where we're going to address it. No, we tend to focus on the human or the physical roots. And then again, for those of you that aren't using trees, you can go with answer 3. Just don't know or not sure.
While folks are answering this one, I have a question for you from the audience. They say it's more of a statement, but do you subscribe to the Six Sigma philosophy that the initial problem that you think it is not actually usually the real or deeper problem?
Wow, great question. Yes, I absolutely do. In fact, during our RCA classes, we use a couple of examples that are real examples from implementations or from incidents that have occurred. And what you see as you dig into those problems is what you believe is your problem statement in the beginning. It may not be the problem statement once you dig down into the problem.
Yep.
And a good example, it's a morbid example, but a good example is a plane crash. That's the problem statement we write down is, oh no, there was a plane crash. But what you actually see is, well, it's not the plane crash that is the real problem statement here. It's the fire that occurred that allowed the plane crash to happen. If that fire hadn't happened, then we could have prevented the plane crash. And so you end up sometimes changing your problem statement. And I know that's a really simple example, but you do, and it does change. So absolutely, I firmly believe that the viewer is right on point.
Excellent. They appreciated your answer. And now we've got some results to talk about here. So 24% are using business case thinking, 59% are focusing on physical and human route, and 16% are not sure.
Okay, good. And I expected that human root and physical root would be pretty high, and I completely
Sure.
get that. I've been there, like I said, I did it myself. But what I will tell you, and I'd be more than happy to chat more about it offline, but what I will tell you is at the end of the day, if you'll take the time to go past that, even if you don't address it down there, it'll give you so much more clarity about the solutions you need to put in place long term.
All right. And I think they also appreciated the scoping advice that you gave earlier, because I think that there was a bit of intimidation about the size of the tree. But when you said if it is, it depends on the complexity of the problem that you're trying to solve, and perhaps scoping the problem down before applying the tree.
Absolutely. That's a great point. Yeah, I mean, I almost hate to use the example that I showed you earlier because it is overwhelming for you as a viewer. But we wouldn't traditionally do that. We would use it as I said, for those specific problems, unless I wanted to make it a teaching point. And I do that occasionally with clients. I'm doing it with you guys today because at the end of the day, it all comes back down to some very specific causes, and those are the things we're going to look at to kind of wrap the presentation up.
All right, back
So,
to you.
thank you. So, a couple things. I do very often see the training word thrown around as a root cause to the problem. I, I'm going to go so far as to say I think that's a cop out. I think that is a very quick way of diverting the blame away and saying that, well, the reason the problem happened is because they don't ever give us the training dollars that we need, and so we're not successful. But it's not my fault. It's obviously the leaders of the organization who hate reliability. Ridiculous. So don't get me wrong, training is a cause, and I completely agree that it is a cause, but there is an underlying root underneath that training. Was the training bad? Was the training not applicable? Was the organization not ready for the training because they didn't understand the importance? They didn't see the value? So you got to understand why you have a training problem, because I definitely agree that training is part of the problem. I'm a training provider, of course I do, right? I definitely believe that training is part of the problem, but at the end of the day, I'm not going to let everybody hang training as the solution to every problem. I mean, I'd love it. I mean, you're just a PO away from your greatest dreams. I'll provide any training you want, but at the end of the day, training is not going to get you there if you don't understand the other contributing factors that were there with it. All right. But when I talk about training, I do like to make sure that folks understand, look at the training you're providing. Do they understand why it's important? Do they see the value? Are you coaching them through that training, or are you just giving them a shotgun blast of training on the way to your next site or on the way to your next area? Are you making them apply that training with a project? Are you making sure that there's a clear plan for what the expectations are coming out of that training? So, training, I admit it's in almost every single root cause investigation that I do, but I still feel like people use it as just an easy to blame, and they really don't get after what you need to do to make that training successful. So here's some of the things I mentioned. You need a good vision and mission. Where are we going? What is the North Star? What is the guiding principles? Where do we want to be in 2 years? So this is an example of an A3 charter, a very simple one. It actually comes from a Six Sigma facility. So those of you that are Six Sigma practitioners, you'll recognize some of this. But the idea behind it is it's very clear here where we're headed. And this is one of the big roots that I see for unreliability in facilities. It's not clear what you mean by reliability. It's not clear where you're going to be in 3 years, and it is absolutely not clear how you're going to get there. So having a good vision and mission statement or an A3 charter can be a great way to get that started. Now, I mentioned that plan. We've got to have a plan. There are lots of different elements. This would be that wide part of the roots as we dig down into the problem. There are lots of different elements that are absolutely critical for good reliability. So what you're seeing here are a list of some of those on the pathway. But if you don't have this worked out and you don't know when you're going to do those pieces, you will be overwhelmed just like you were when you looked at my root cause fault tree a few minutes ago. All right, it's overwhelming. You've got to have a clear path. You need to know how you're going to implement this. And I could probably talk to this slide for the next 30 minutes. We won't. But the point is, you need a pilot area. If you don't believe me, let's talk about it. Because if you're trying to just do a little bit of this here and a little bit of that there, and we're going to do a little bit of this year, and we're going to do a little bit of planning next year and a little bit of PDM this year, what I will tell you is at the end of the day, your success will be so slow that you will lose interest unless you're just incredibly dedicated, and you will end up not getting the results you expect. So another one of the roots that come out as you dig down into these problems is you have to have an implementation plan. You have to know where you're going to take this. You have to get success, and that success will breed more success across the rest of the organization. Now you can hear me kind of saying plan, plan, plan. You have to have a plan. In fact, many of the plants that I see that are suffering for that tree of unreliability are not suffering because they don't know what they need to do. They're suffering because they're overwhelmed and they don't know when they need to do it. You have got to take the time to build a plan that tells me what I'm going to do, when I'm going to do it, and how I'm going to get there. I could spend quite a bit of time here. I can't today, but I can show you the science. I can show you the reason this plan's important. And if you're not using a plan and you're not updating a plan and you're not keeping that plan moving forward, then I will tell you your implementation will take longer, even if it ever becomes successful. Now, risk. One of the things that I definitely see as we drill down into unreliability is that folks don't understand all the potential risk that are a part of being more reliable. So you need to take the time. This is a simple SWOT analysis, but you need to take the time to understand the strengths, the weaknesses, the opportunities, the threats. Take the time to understand where your risks are, and that's going to help you create a plan that addresses those. And again, those of you that know me know I could soapbox topic about all these, but my point for you guys is at the end of the day, if you dig down into that pyramid that I showed you, what you start to find is things like leadership, things like planning, things like communication, things like understanding the risk. All right, all those things you've heard me talk about many times. So if you've ever wondered why those are so important to me, they're important to me because they're at the roots of the issues that we're facing. If you're using a plan, I've put a few kind of key success factors in here for you. I'm not going to read them to you today, but I will put them up there so you can see them. The presentation will be available and you'll be able to go through these in more detail. But the plan, guys and gals, is absolutely critical. I can't tell you how important it is. And it's not just something you create at the beginning of the project. It's something you use to manage the project going forward. It will grow. You will add details. You will have to put in more content, but it allows you to see where you are, where you need to go. The other thing for some of you that are more project engineers, I want you to realize that when you're implementing reliability, you're changing culture. And when you're changing culture, it doesn't always stick to the dates of the plan. So they may move around as time goes on, but as long as we know that they've moved and we know what we need to do, then the plan is still driving success. Now, the other thing that you guys have always heard me talk about is understanding how to manage the change, because at the end of the day, whether you're implementing planning and scheduling or predictive maintenance or reliability centered maintenance or TPM or any of the other flavors of reliability improvement that are out there, you've got to get people to do something differently. And if you don't, you won't be successful. Two tools that I think you need, you've heard me talk about them many times before, are right here on the screen. Take a look at them. You can Google them. The first one is the ADKAR model, and the second one is the Cotter model for effective change. So you can take a look at those and dive a little deeper. I love them. I've seen them work. I know they will work. And so I really do recommend you taking a deeper dive into these. Now, the last thing that I want to talk about today, and this is one of those causes that are down there near the bottom of many of these investigations, and that is that the organization doesn't see the value in XYZ. They don't see the value in predictive maintenance. They don't see the value in planning and scheduling. They don't see the value of reliability. They don't see the value of precision maintenance. They don't see the value. And I think the reason for that is a lot of times we just don't sell the value. And you need to think about both the short term and the long term. You need to think about both the political things that will drive it in the organization, the logical things like the money, which I'm going to show you next, and the emotional things. All of those are tools that you can use to sell your reliability improvement. And it goes back to that root in the tree that many times doesn't get addressed, and that is that lack of understanding of the value to the organization. So I've got a simple example. This is our last real slide before we start to wrap this thing up. But I've got a simple example here of a way to show the value. And this one is very much for the logical people. It's show me the money. It's dive in and tell me what I can save if I do something differently. And this is excellent. And it is very important. But don't forget the other two. Don't forget that emotional, and don't forget that political moving forward. So with that said, I'm going to kind of wrap up today. As you can probably tell, there's a lot we could unpack here and a lot we could spend a lot more time with. But I really wanted to just give you guys a quick look at why these motherhood and apple pie topics that I tend to talk about a lot here on the Fluke series, why they are so important. And at the end of the day, they are important because when you drill all the way down into the problem and you get down to the bottom of those diamonds, these are the things that I see over and over and over. Thanks again for joining me. I hope you've enjoyed what we've seen. If you want to talk more about some of the things you've seen, here is my email address, and then underneath it is my cell phone number. Would love to chat with you. Especially in this time of COVID, it's always great to get out and talk with people. Even though you can't do it face to face, we can do it on the phone. So feel free to reach out, and thanks again for joining me for the presentation today.
I think there was a lot of very hard, close listening happening, Shon. And I want to encourage people to type in their questions now, because even though we won't be able to answer all of them live, Shon will follow up with you afterwards. So it's an awesome opportunity to get more of your questions answered. Shon, I do have one question for you now. Can you have more than one root cause, for example, both a human and a systemic?
So there won't be one. Let's see. I'm gonna answer this question two ways. Yes, but there are always more than one cause.
Right?
So if you think about anything, there's going to be an action and a condition. So the short answer is yes, you can always have more than one cause. And the second thing is yes, you will always have a human level cause, and you will have a systemic level cause underneath it. So you will always see a human. If you think about the problem, there's going to be somebody who did something wrong. All right. But underneath that is a system that allowed that person to do it. So yes to both questions.
People are looking forward to getting the slides. Do you have any advice for folks as they're reviewing what you've talked about, some first places to start?
Yeah, I mean, I think from an advice standpoint, it can be very easy to just go after root cause and in the morning meeting start requesting everybody do RCAs, and they have to have 20 boxes and they have to use a fault tree. And I don't suggest that. I suggest that you build a process for how and when you're going to do RCA and how many people are going to be involved. So I always talk about an acronym PPT. You need to have a good process that works with your people to use your tools of RCA. And so you want to have that PPT in your system before you just start asking people to do RCAs.
Excellent. And obviously there's a lot more information on eruditio.com, and I can confirm if you email Shon, he will answer. Shon, if you'll forward to the next slide, I want to give a
Absolutely.
sneak peek to our next speaker, Chuck Pettinger from Predictive Solutions. He's going to be talking about building a culture of safety beyond a pandemic. So great follow-up to this topic, right? Another area where culture is essential. So I want to encourage everyone to attend because Chuck has a really good approach to building safety into the fabric, just like you're talking about here. And he'll have some good thoughts on the short term and the long term that we're facing and talking about a lot right now. And then if you'll forward one more time for me, Shon, I want to remind people to stay online after I close the webinar because that survey is going to pop right up. And we would love it if you could give us feedback both on today's presentation, about the next topic you'd like to hear, and also if you want to get a copy of the presentation, if you want to get a certificate, please answer the survey. All right. The recording of today's presentation will be online in a day or two. Go to excelix.com and look at the on-demand webinars, because that is it for today. Thank you so much, Shon. It was such a pleasure having you on today.
Thank you for having me. It was great to be here.
Fantastic amount of information in 1 hour. You did a great job, and we'll see you back again soon, I hope.
All right. Thank you. Have a great
Thank
day,
you,
guys.
everyone. Yep. Have a great day, everyone.